page 42 when we're done. We're going to talk about inverse relations and functions. Now, inverses are something that you've done in Algebra 2 as well. You didn't really talk about domain with them, and we're going to look at domain a little bit today with them, but inverses should not be brand new to you. So, it says, what is the inverse of a relation? To find the inverse, what do? We switch the x and the y. Very good. Okay, so, and what is an inverse relation? We're going to say a relation that exchanges x and y and is a reflection in the line. What line does it get reflected in? Come on, you know this. Y equals x. Because y equals x, x equals y, right? So it's a reflection in the line y equals x. To actually find it, we just switch x and y. That's it. Okay? Now we're going to talk about relations and functions. Right now we're just talking about relations, right? Any graph is a relation. They're not all necessarily functions. So our notation, the inverse of relation r is written as r, looks like r to the negative 1 power, but that's the inverse relation. And if I want to give this inverse, right, so here's my relation and there's some ordered pairs. All that you do for the inverse is you exchange x and y. So instead of 0, negative 7, we'd have negative 7, 0. And then 2, negative 1. Negative 2, negative 4. And 3, 6. The signs go with it, right? Just literally exchange them. Okay. So that's just a relation, not necessarily a function. So let's talk about functions. A one-to-one function. Okay, so if we're looking to see if something is a one-to-one function, so a function has a one-to-one relationship if the relation, relation and its function no wonder sorry, not and its function, that makes no sense. And its, well, erase that word. If the relation and its inverse are functions. That's what I was going for. Okay. So it's a one-to-one function if the graph itself is a function and the inverse is a function. So even if you have a function, not every function has an inverse that's also a function. It has an inverse, it just may not be a function. Okay? And to figure that out, we have something called the horizontal line test. Y'all know what the vertical line test is, right? Vertical line test tells you whether or not you have a function visually. Okay, and that's what this says right here. The vertical line test is used to determine whether a relation is a function given a graph. We understand that, yes? Okay, so the horizontal line test, same idea, but now we're going horizontally, so the horizontal line test is used to determine whether the inverse of a relation is a function. So we can look at something, vertical line test, we have a function. Horizontal line test, if it fails that, then the inverse is not a function. We don't have to actually graph the inverse. So both the relation and its inverse must be a function in order to be one-to-one. Okay. Both of them have to be. So it says determine whether the relations are one-to-one functions. So if you look at number 1, does number 1 pass the vertical line test? Yes. So vertical line test here, it's a line, it's a function. Does it pass the horizontal line test? Yes, which means the function and its inverse are both functions. So then the answer is yes, it's one-to-one. Okay? Yes. All right, so number 2, does that pass the vertical line test? Yes, it passes the vertical line test, right? This is a function. Totally passes the vertical line test. Does it pass the horizontal line test? No, because my horizontal line test, if I just did right there, I've got 4 intersections right there. Totally fails the horizontal line test, so the answer here is just no. Okay. All right, so number 3, is number 3 a function? Yes, okay, it's going to pass the vertical line test. Does it pass the horizontal line test? Yes, it does. So it's going to be yes, 1 to 1. Number 4, does it pass the vertical line test? Yes, we have a function. Does it pass the horizontal line test? Yes, because this function here that's graphed is a cube root, right? Or it looks like a cube root function. It's going to be cubic, so it's going to be yes, 1 to 1. They are both functions. All right, is number 5 a function? Yes, it passes the vertical line test, right? Does it pass the horizontal line test? No, it doesn't, because there's an infinite number of points if I go through right there, right? So this is a no. This is a horizontal line. The inverse would be a vertical line. Vertical lines are not functions, right? Okay, so does this pass the vertical line test? No. Okay. Would it pass the horizontal line test? Yes, but the answer is no, because it's not even a function to begin with. Okay. Everybody okay with that? That easy enough? Okay. So graphically, we've got the vertical and the horizontal line test, right? Now, inverse functions. So our notation, the inverse of a function, so if I have f of x, it's written as the f inverse of x. It looks like f to the negative 1 power. Not all functions have inverse functions. That's important to remember. Just because what you have as a function doesn't mean the inverse will be. So to find the inverse of a function, we replace f of x with y, then interchange x and y, solve for y, and then rewrite it as the inverse. So before we even start, we want to decide whether or not we would actually have a one-to-one function, right? So it says determine whether or not it has an inverse. That's important because I might be doing work for nothing. If yes, I find that and I state any restrictions on the domain. All right, so when I graph, what's the parent function for this function here? It's linear, right? So if I graph just a linear that's not a horizontal line, is that going to have an inverse? Yes, so it's going to have an inverse so I can move forward. So I can replace f of x with y. Then I'm going to exchange x and y, right? So I get 4y minus 8 equals x. Everybody with me so far? Then I'm going to solve for y. So I'm going to add 8 to both sides. So 4y equals x plus 8. Then I'm going to divide by 4. So y equals, that would make this what? What goes with my x? 1/4 x plus what? 2. You got to divide both of them by 4. So now I have solved for y, so the inverse of f of x is equal to 1/4 x plus 2. Do I have any domain restrictions? No. It's a line, and I'm good. Everybody okay with that? All right. Let's do number 8. What's the parent function here? Cubic. So it's going to look like this, right? And is the cubic a function? Yes. Does it pass the horizontal line test? Yes. So I also have an inverse function, right? So I set this equal to 1. I'm not equal to 1, duh. Equal to y. Sorry, making stuff up. Then I exchange x and y. So now I have 1/2 y cubed minus 1 equals x. Okay. So then I need to solve for y, right? What should be the first thing I do? Add 1 to both sides. So I get 1/2 y cubed equals x plus 1. Then what should I do? Multiply both sides by the reciprocal, which would be 2. So if I multiply both sides by 2, that'll give me y cubed equals 2 parentheses x plus 1. Now, I could distribute, but I'm not going to, and I'll explain to you why at the end. But those parentheses there are important, right? I can't just put a 2 out in front of the x. We're all good with that? Still got to get y by itself, so what do? Cube root, right? So I have to take the cube root of both sides. So y is equal to the cube root of 2 times x plus 1. Can I simplify that any? No, I cannot, and that's okay. Is all that supposed to be under the cube root like I have it? Yes, okay. So you've got y by itself, right? So now I can just say that the function inverse of x is the cube root of 2 times x plus 1. Now, here's why I didn't distribute that or worry about anything else. If I'm going to go graph this, which eventually we're going to graph them, don't I want this factored out like this? Yeah, so I have that. This 2 represents what graphically? Horizontal compression of 1/2, right? And then this would mean that I move to the left one. Like it's already set up for me. Whereas if I distribute, I'd have to factor it back out before I go and graph it. So which is why we just leave it and learn how to leave it. Okay, we all good? Do I have any domain restrictions? No. Okay, because I have it's a cubic and then it's a cube root and my domain's all real numbers. We're good. So now let's look at number 9. If I graph this, what's the parent function? Quadratic. So here's my quadratic, right? It's a parabola. So we know it's a function, right? But it doesn't work. It fails the horizontal line test, right? Fails the horizontal line test, so guess what? I'm not going to do any work because I can't find the inverse function anyway. So we just write no inverse, and that it fails the horizontal line test. Make sense? Because if we reflect it in the line y equals x, what we get is this. Okay? Yeah. Because once you actually have the inverse, it's because the inverse fails the vertical line test, right? And so the original fails the horizontal line test. Okay? We all good with all that? All right, so let's look at number 10. When I graph this thing, what is the parent function here? Reciprocal. Okay, so my reciprocal function looks like this, and I have asymptotes that I'm not drawing in there. We know that's a function. Does it pass the horizontal line test? Yes, it does. So I have an inverse function. So I set this equal to y. Then I exchange my x and y, so I get 5 over y minus 8 equals x. Okay. First thing you want to do most of the time is try to get rid of the fraction, right? So I want to get that y minus 8. Can I just add 8 to both sides? No, I got to get rid of the whole denominator, right? I do that by doing what? Multiply it by, okay, so I could just multiply by the reciprocal of this, right? But if you always think, I always want to do the opposite. This is being divided by y minus 8, so I'm just going to multiply both sides by y minus 8. So that's going to give me 5 equals x times y minus 8. Does that make sense to you? Now, what am I trying to get by itself? Y. So should I distribute that x in there? Not at this point, because I can just move the x over, right? And I move the x over by doing what? Divide by x. So that'll give me 5 over x equals y minus 8. So then what do I do? Add 8 to both sides. So when I do that, is that going to give me 13 over x? No. I have 5 over x equals y. Now, I could get a common denominator here, but I don't need to. And if I don't, then I can see what I'm supposed to be graphing, right? If you think about it from that aspect, this is just your vertical shift here. So your function inverse is of x equals 5 over x plus 8. Like this. Now, do I have any domain restrictions here? Yeah, I actually do. Because I had some domain restrictions originally, right? So up here, this is just my parent function. If I was to actually graph this, what does this 8 do? This 8 right here. We would move to the right 8, yes? And so since I would move to the right 8, I'm just going to kind of sketch it out so that you get the idea of what I'm trying to say here. It would look like this, and yeah, there's a stretch and stuff, but it would look like this, right? There's not a vertical shift, it's just horizontal shift, right? And this right here, this would be at 8. Okay. So my domain just goes from negative infinity to 8 and then from 8 to infinity. My range goes from negative infinity to 0, because I have an asymptote here too, right? And then 0 to infinity. You with me on that? Because we switch x and y, what else changes places? domain and range. Because check this out. If I was to graph this, right? This is a stretch, okay? And I just shift up 8. If I'm just shifting up 8, does it change my domain from the original? Okay, just a shift up doesn't change the domain, right? So, and guess what? X can't equal 0. Just like here, you see how X can't equal 0? So that means my domain here would be all the x's such that x cannot equal 0. Or I could say from negative infinity to 0 and 0. But I also can tell from this that I can't divide by 0. Okay? But what happens with the inverse is that the original domain and range, they just switch places. Domain becomes range and range becomes domain. Okay? We good with that? And that'll help you understanding that with some of them. Questions? Okay. Let's look at 11. So on 11, I have, this is a square root function, right? So this is my parent function. Does it pass the horizontal line test? Yes, it does. Therefore, I have a function, so I can find the inverse. So this is going to give me negative square root of y plus 2 minus 7 equals x. I'm trying to solve for y, right? What's the first thing I have to move? Add the 7. So I'm left with negative square root of y plus 2 equals x plus 7. Now, I need to take care of that negative before I do anything else. So what do I do with that? Okay, divide by -1 or multiply by -1, does it matter either way? Okay, so I'm going to multiply both sides by -1. So I get square root of y plus 2 equals negative times x plus 7. Again, I'm not distributing because I want it factored out if I have to graph it eventually. Does that make sense to you? Okay, so now I got to get rid of the square root, so what do I do now? Square both sides, so then y plus 2 is equal to negative x plus 7, like this, right? But this whole thing gets squared. Does that make sense? And then I have to subtract 2, so yeah, y equals parentheses negative parentheses x plus 7, close, close, squared minus 2. And that is your inverse function there. Okay, everybody good so far? Now, let's talk about domain restrictions here. Do I have any? Yes, because if I graph this as it is, what am I going to get? What is this? Just look at the function itself. It's a quadratic, right? And if I just take this and reflect it in y equals x, am I going to get a quadratic? No, I'm not. So let's think about what we actually get here. This actual function here, if I was going to graph that, it's going to be, so this is my parent function, right? It's going to be reflected in the x-axis, so now it's looking like this. This means I go which way? Left 2 and down 7. So I'm like here, right? So it's something like this. I mean, we're just trying to ballpark it here. And this point here would be negative 2, negative 7. Everybody with that? So the domain of my original function here would be from negative 2 to infinity. Make sense? When I reflect that in the line y equals x, so y equals x, x equals y, and it's going to flip up here, these two things change places. Now I'm at negative 7, negative 2, and it looks like this, right? But it's not the whole quadratic. It's just part of it. You agree with that? How could I know what my domain is without having to draw this and figure it out? How is it related to the original function? It's not the domain of the original function, it's the what? It's the range, because they changed places here, right? The range of this function, all the y values would have to be less than or equal to negative 7. You agree with that? You see how all of your y values are less than or equal to negative 7? When I actually draw this out, look at my x values. They're all less than or equal to negative 7. Does that make sense to you? So do you see how you don't have to draw this out and figure it out? You can figure out the domain and the range of the original one, which you need to be able to figure out from the function itself. So if I get this, for the original one, my domain would be that x has to be greater than or equal to negative 2. And my range would be that y has to be less than or equal to -7. Do we all agree with that? And then since x and y switch places, the domain of this one becomes, this is now an x has to be less than or equal to -7. Okay, so they switch places even in the domain and range. Everybody okay with that? And you can figure out a bunch of different ways. You can figure it out from the final one or from the original one, but just know you can just take the original one, figure out the domain and range, and then they just switch places. Okay, we all good with that? All right, let's look at 12. When I graph 12, what does it look like? Or what's this parent function? Absolute value. So it looks like this. Does it pass the horizontal line test? Nope. So this has no inverse, or no inverse function, I guess I should say. No inverse function. And because it fails horizontal line test. And there's, oh, not text, test. And so there's no work to be done. Oh, test. Okay, there we go. Everybody okay with that? Any questions? All right, let's look at 13. What's my parent function? Cube root, good. So this is what my parent function looks like. It passes, right? So we got to do this one. So this is equal to y. Then I change the x and the y. So y minus 9, cube root of y minus 9 over 4 equals x. Okay. I want to move that 4 first. So what do? Multiply both sides by 4. Because this is being divided by 4. I multiply both sides by 4. So I'm going to get the cube root of y minus 9 equals 4x. Then what do I do to get the y out from underneath there? Cube both sides. Good. So I'm going to get y minus 9 equals 4x. And this whole thing gets cubed. But I'm not going to actually do it. Okay? And then I add 9 to both sides. So y equals 4x quantity cubed plus 9. So that means the function inverse of x is 4x cubed plus 9. Everybody okay so far? Okay, so when I did this with my other classes the other day, I had somebody say, well, because I guess he just got ahead of me, but instead of having this, he actually cubed 4. So what's 4 cubed? 64, right? 64. So this would be y equals 64x cubed plus 9. So we said, well, I did this. Is this the same thing and is it okay? It's fine, right? It's fine either way. And actually on this one, I could graph either one of them. But you got to know what the numbers mean. This 4 here represents a what? When I do transformations? Horizontal compression by a factor of 1/4, right? This 64 represents what? Vertical stretch by 64, right? So if you think about this, we have, if this is a, whether I take this and I compress it horizontally by 1/4, okay, it'd be as skinny as this, or I take it and I stretch it by a factor of 64, I'm going to get the same graph. On the little grids that we have, which one's going to be easier to graph? This one, right? And plus, if you get to stop, stop, so you don't accidentally cube a number wrong. But regardless of which one you graph, you're going to get the same graph. The same thing happens either way. Okay. All right, let's look at number 14. All right, so when I graph this, I got our domain restriction here, right? When I graph this, if I didn't have my domain restriction, what would I get? A quadratic. If there was no domain restriction there, if this wasn't there, I'd have a quadratic. But I only want it where x is greater than or equal to 0. Well, this is a vertical stretch, right? And this is a horizontal shift. So since I don't shift it left or right, then which part of the parabola do I get if all my x's have to be greater than or equal to 0? Do I get the right side or the left side? The right side. And it's stretched by 3 and shifted down 1, so I kind of get this right here, right? That's what the graph would look like. Does that pass the horizontal line test? Yes, it does. So since that passes, I can set this equal to y. They're going to change places, so I get 3y squared minus 1 equals x. So I add 1 to both sides. 3y squared equals x plus 1. Then what do? Divide by 3. I want to divide by 3, right? And so I'm going to divide by 3, and I'm going to get y squared equals 1/3. That's the same as dividing by 3, right? Times x plus 1, because this is really how I would like to see it inside of what's going on. I want to multiply by 1/3 because that's going to tell me what's going on with my x, right? Then what do I do next? Square root. So that means that y equals the square root of 1/3 times x plus 1. So my function inverse, for x, equals the square root of 1/3 times x plus 1. So now, do I have any domain restrictions? Yes. Let's go back and look at our original one here. Here, my domain of the original one is this. I already knew that. X is greater than or equal to 0, right? What's the range? Because look what this did. This stretched it, right? But then it shifted down 1, so your y values would have to be greater than or equal to what? -1. So down here, your domain restrictions would have to be that the domain, the x's have to be greater than or equal to -1. Okay? Everybody okay with that? Wait, I did something wrong somewhere. Oh, no, I didn't. I did something wrong on here. Look at that. Okay. No, that's right. Okay. Just bad feeling. Oh, my work is. Okay. All right, any questions? Second guessing myself because I wrote something down wrong on my paper, but it's correct up here, so that's all that matters. All right, we're all good? You good with inverses? Okay, so you've done inverses before, right? You've switched x and y and you've solved, but I don't know that the domain that you've really looked at that. So find the domain in the range of the original one. Just know that they change places. Your range becomes your domain. You're done. Okay, does that make sense? And if it's all real numbers, you don't even have to mention it. All right, any questions? Awesome.